Okay, this video is for problem number 11 on the in-class review. So this one is like the lab that we did where a student is trying to figure out the formula for some metal that combines with oxygen. In this case it's copper. So what they did is they took an empty crucible, put some copper in the crucible, heat the crucible up until it reacts with oxygen, and then remass it to find the mass of the copper oxide. Okay, so we're going to use the data below to figure it out. So the first thing is we've got to find the mass of the copper. So we're going to need to know two things, the mass of the copper and the mass of the oxygen that combines. So to get the mass of the copper, you look at, well, they have the crucible here with copper, and then they have the empty crucible. So if you just subtract the two, so if you subtract 75.72, subtract 74.30, you would end up getting the mass of the copper, and it's 1.42 grams. All right, so we know that the student is starting off with 1.24 grams copper. All right, and so what we're going to do is change it to moles. So take your grams and change it to moles. So 1 mole copper, you look up the molar mass in the periodic table, and I'm just going to round it a little bit. It's 63.5 grams copper. And you do the math there, and you get 0.0224 moles copper. Now you're going to do the same thing. You got to figure out the oxygen. So basically, what they do is they heat the crucible with the copper. So this is the crucible with the copper in it, so that there's the copper in the crucible. They're heating it up with a Bunsen burner. Okay? And so then the oxygen is coming in from the air to combine with the copper. So afterwards, you end up having a crucible. Not only is the copper still there, but now it's got oxygen with it, okay? So the question is, what's this formula? Well, if we take the crucible with the copper and oxygen minus the crucible with just the copper in it, we'll get the mass of just the oxygen. So we would take 75.90, subtract 75.72, and what you end up getting is 0.18 grams oxygen. So you go 0.18 grams oxygen. Make sure you keep it just O and not O2. It's not oxygen gas, it's oxygen in some sort of compound. I mean, it used to be a gas, but it's not anymore. So just keep it as O. So we'll go 1 mole oxygen, and that's 16 grams oxygen, the molar mass. So we'll change that to moles, and we get 0.0113 moles oxygen. So our formula is Cu 0.0224 O 0.0113. But we're not done yet because we have to put it in a whole number ratio. So to do that, you take the smallest number of moles, the one that's the smaller, and you divide it by itself. That's going to equal 1. Then you take the bigger number and you divide it by the smaller number. And in this case, when you do that, it equals something like, I'm just going to write it over here, it equals something like 1.98. So basically what we have is we have copper 1.98, oxygen 1, which basically the 1.98 can just be rounded off to 2. So it's Cu2O. And that would be the formula of our copper oxide. Okay, that would be copper 1 oxide is the name of that. But there's 2 coppers. Okay, that's it for this video. I'm having trouble with my mouse here. All right.